little did you all know that Hunk is actually a woman. I joined April in 2014, so I've been at Splunk for a whopping 5 months. Really excited to be at my first conf. I don't know if you guys know, but internally all of our releases are currently named after My Little Ponies. So I have a secret wish that the next releases will be named after Care Bears. That'll give you an idea of when I was born. And my favorite Splunk t-shirt is I like big data and I cannot lie. So of course that would be my favorite t-shirt.
Just a bit about what we're going to talk about today. First, we're going to go over what features are new in Hunk 6.3. It's just a good opportunity to give everyone an overview. Then I'm going to go over some background about how Splunk stores data internally. I apologize if this is review material for some of you or not quite what you were expecting, but it's important to help you evaluate what some of these archiving solutions are and why some are better than others. After that, I'm going to start talking about the various options. We're going to start off with the non-Hadoop archiving options. These are all going to be things you can use even if you don't have a Hunk license. They're all available in Splunk Enterprise. And then I'm going to talk about what Hunk brings to the table, which is archive indexes and how those fit. We're also going to talk a bit about how those fit into your overall big data ecosystem.
Thanks, Kate. Before I get started, I just want to, by show of hands, how many of you are using Hunk today? Great. How many people are using Hadoop today? Great. And is everyone using Splunk Enterprise? Great, great. So you're in a great session with Hunk 6.3. We've really focused on the Splunk Enterprise customer. So I wanted to come in and join the session with Keith just to give you a brief overview of the new features in Hunk 6.3. Nate went over some of these features in the keynote this morning, but I wanted to spend a little bit more time going into a bit more detail on the new features. So with Hunk 6.3, as I mentioned, we really focused on the existing Splunk Enterprise customer. So for Splunk Enterprise customers who are using Hadoop or who are looking to adopt Hadoop, how do we make it better and easier and more functional for you to use Splunk Enterprise and also get value out of your data in Hadoop at the same time? So the first thing that we focused on was helping you drive down your total cost of ownership or your storage costs with the archive to Hadoop feature. The second area is making that data more accessible, so providing open access to Splunk Enterprise data. So for those of you who don't know, we index Splunk in a proprietary format called journal.gz, and we also archive in that proprietary format. But with Hunk 6.3, we're making that access available to your existing Hadoop tools. So for all of you who raised your hands saying that you're using Hadoop today, you're likely using Hive or Pig or some other third-party Hadoop tool on that data today. And now you can use those tools on top of your Splunk data as well. And the final thing is, for those of you who haven't used Hunk before, Hunk was always packaged separately from Splunk Enterprise. So you downloaded bits for Splunk Enterprise and then you downloaded bits for Hunk. With 6.3, we've combined that into a single package. So it's a single download and it's a single install. It's just separate license keys that you need to have. And so because of that, and because we're on the same platform as Splunk Enterprise, we're able to take advantage of a lot of the features that you heard in Enterprise 6.3 in Hunk as well. So namely the advanced analytics and visualization capabilities that you heard on stage about Splunk Enterprise this morning. So firstly, I'll go into the archive feature. So with existing Splunk Enterprise installations, for data that's in any warm, cold, or frozen bucket, you can archive that data easily to HDFS using Hunk, so HDFS or S3 on Amazon. So the only thing that we won't archive is hot buckets because they're still being written to, but anything that's in a warm, cold, or frozen state can be easily archived through the UI into HDFS or S3 to help you lower your storage costs. And what we've seen running some of the numbers and talking to some of our customers who've been looking at this archive feature, they're looking at storage reductions of 75% or higher by moving some of those Splunk indexes into low-cost commodity storage on HDFS or S3. But what's really important is that we still let you use all of your tools that you know and love from Splunk Enterprise on that archive data. So it's the same user interface, same search processing language, same queries, same indexes. You don't need to change anything, and now you can run what we call a unified search across that real-time data or recent data that's in Splunk, in the Splunk index, and then across the archive data that you've put into HDFS or S3. So where we're hearing customers, what kind of use cases that we're hearing is, for example, financial services, where they're really only searching in Splunk the first 90 days of data is the recent data that they really want available that's in a performant manner. But for auditing reasons, they have to keep 1 year up to 5 years of data that they're not really searching or analyzing. So they don't need the same performance, and so they're rolling that data into HDFS to get the lower cost savings, but then still being able to search across the real-time and recent data in Splunk Enterprise without changing everything. So for all of you Splunk ninjas out there, same skills apply on the Hadoop side with the archiving feature. The other area is opening up that access of the Splunk data to third-party Hadoop tools. So as I mentioned a little earlier, for those of you who have Hadoop in your organization, you're probably got Hive tables or you're running pig scripts against the data that's already in Hadoop. Now you can use those same tools against the data that you've archived out of Splunk Enterprise as well. So Keith will go into a lot more detail about the archive record reader. But now all of your data scientists, analysts in your organization who aren't necessarily using Splunk, but using one of these third-party Hadoop tools can now also access that Hadoop, the archive data in Hadoop in the tools that they're familiar with. The last area I'll go into, as I mentioned, taking advantage of the Splunk Enterprise platform. We've got some new visualization and analytics capabilities in Hunk 6.3 that are really geared towards customers who are analyzing big data. So one of the new features is anomaly detection with Hunk 6.3 and the geospatial visualization. So you saw this in the keynote earlier where Nate did the phone shake and you saw all of the data come up on the map and the choropleth map capabilities. That's also available in Hunk 6.3 as well. And then the new single value displays, which allow you to give more context to your big data. So you can change the format, add spark lines, really make those single value displays much more prominent depending on what you're monitoring in your organization. And the last thing that I'm really excited to talk about is the free Hunk licenses. So for those of you who have an existing Splunk Enterprise license and you're indexing 100 gigs or more per day, will all receive a free Hunk license. It's a 1-year term license for 5 nodes of Hunk. And just to give you an idea, we've got a blog post coming out tomorrow, but looking at some of the calculations between Splunk index running 100 gigs or indexing 100 gigs of data per day versus Hadoop on 30 days on a Splunk index, you can store about 24 months worth of data in Hadoop for that equivalent in those 5 nodes that we're giving for free to all of the conf attendees. With that, I'll pass it over to Keith.
Thank you. My mic thinks it's on. Hello, hello, hello. Hello? Hello? There we go. Mike? Hello? Okay, it's being finicky. I'm just... Let's try this again. I think that's a little better. Okay, great. So I wanted to start off by talking a little bit about why is archiving important. Anytime you're using a sort of big data system with large ingestion rates, you realize pretty quickly that you're up against 2 competing forces. One is that data is good. The more data we keep around longer, the more we can do with it. Long after the data is no longer useful for the day-to-day running of your business, you still want it for historical modeling. So for all these things we're interested in, the effective sales, IT provisioning, security issues, all of that, you want to know how that's going to respond to seasonal variations, to changes in the economy, to the launch of new products. And for all that, you need to keep data around for a long period of time. On the other hand, one other thing is, depending on which industry you're in, you may have some very strictly defined legal requirements for data retention that you're not allowed to violate. On the other hand, the more data you keep around, the longer, the more money you have to spend. And the more of that that's kept in its original state in a production system, the worse that's going to be. So the exact balance of these two forces against each other is going to depend on your individual situation. And so that's why our goal is to give you as many options as possible to find the balance that's right for you. So I'm going to start, like I said before, with reviewing a bit about how Splunk and Hunk store data internally. This is a typical three-tiered architecture for a typical Splunk deployment. The data, closest to the data is the forwarders. Those live where the data originates, and their only job is to send the data on to the indexers. The indexers are responsible for storing the data, for maintaining indexes and other structures that can help us search the data later, and they're responsible for running searches over the data that they have under their control. The part you interact with as a user is the search head. I'm showing it here as one machine. Of course, these can be clustered. You might have a large number of them. Conceptually, it's one box. This is what provides the web interface where you put your queries in. It's responsible for federating those queries out to the various indexers and then for collating the results that come back. In addition to that, if you have Hunk, you can also use what are called virtual indexes. Virtual index is an index where the data resides on a non-Splunk system. Most of the time we're talking about Hadoop, and so that's what I'm going to talk about here. See that over here. You can also see that Hunk can also deal with regular old non-virtual indexes as well. And this is important. Now that these two things are combined into one set of bits, you can manage both virtual and non-virtual indexes from the same deployment, and you can include them in the same query. So what's going on with Hadoop? Well, we've got data that's probably living in the system because of the overall how you've structured your data flow. You've got things like Flume, Scoop, etc., moving data onto Hadoop, and you're living in some directory structure. Well, with Hunk, you don't need to ingest that data into Splunk. You just point the search at a certain directory within some form of Hadoop-compatible file system, HDFS, S3, etc. And now you can treat that as an index. We're going to farm our queries out as MapReduce jobs, in particular as mappers, and you're going to get back results. They're high performance in some ways. You can get incredibly high throughput rates, but because of how Hadoop works, you're going to have higher latency than you would with a regular Splunk non-virtual index. Data is stored within Splunk indexes, so non-virtual indexes, in things called buckets. This is basically a chunk of data that represents a finite period of time. So all the events within a bucket are going to belong to the same index and belong to that period of time. And buckets age through the system. Age through the system like that from hot onward. The important thing to remember about these various life cycle stages that they go through, they're only being written to in the hot stage. After that, the events that are in a bucket are fixed. They're not going to change anymore. And events remain searchable and analyzable until the bucket gets to frozen. Frozen is defined as that stage where the data is no longer searchable. This is the typical path that the data moves through the system. Here's how they will age normally. You can see that where these buckets are stored is completely configurable. We provide a different path for cold buckets than for hot and warm buckets. The older the data is, the less likely it is to be relevant to a given search. So a lot of people like to use slightly cheaper, slower hardware for their cold path than for their home path. That's an option. Once the data is in the frozen state, it can't be searched unless you manually make it searchable again That's fairly easy. Just move the bucket or copy the bucket from frozen to a path that you specify called the thawed path for that index, and Splunk will automatically pick it up again. It's then, you've now manually intervened, so it's going to stop aging, and you'll have to decide how long you want it around, after which you can flush it. These are some of the configurations that control when buckets move from one of these phases to another. As you can see, they're controlled in a couple of different ways. One is by the data size within various stages. So you can say that this is being stored on a 10 terabyte RAID, and somewhere around 8 terabytes you need the data to fall out of the system. It can also be controlled in some cases with a number of buckets, and in some cases with a total age. So for example, if you want to say that after a year this data is no longer relevant, or you have a retention policy that says you need to uniformly get rid of data after that amount of time, then you can set the frozen time period in seconds, and after that amount of time it's going to roll over into frozen. I should say that amount of time after it's gone to cold. So what does it mean for a bucket to become frozen? I kind of glossed over that a minute ago. This is very important. By default, frozen means that a bucket gets deleted. If we haven't specified what else to do with it, the assumption is at the time that it's frozen, we've run out of space on local storage. So this is a reasonable thing to do. The defaults are, I believe, roughly 500 gigabytes within that index, or 6 years. So those are fairly reasonable, constraints. So most of the time, this is just fine, but not always. Again, you might have some very fine-grained legal policies, and you might not want to wait that long. You might want to minimize TCO by doing something else with the data sooner than that, but you're not comfortable. If you're moving that data up, you're not comfortable getting rid of the data altogether. You want some in-between step. So there's a few alternatives that you can use here. One alternative is to archive data to some other location on your file system. This is simply telling Splunk that you want to copy the data to another directory. For example, you could have a file-mounted NAS or SAN on the system where you're sharing storage with other servers, and so that's generally going to be cheaper to maintain. This is really simple to do. You just specify one configuration within that index. It's the cold to frozen dir, and automatically, when a bucket is frozen, it will get moved to that location. The downsides are it has to be something that's accessible via the file system, right? So if you, for example, if you have a tape backup system that doesn't use a spooling directory, then you can't use this. Also, the data, as I've said a few times already, it's not searchable at this point. It's out of Splunk's control. If you discover that you have a need for that data, you have to manually move it back to a location where it's going to be searched. So what if you want finer grained control than that? Well, we also provide an option where you can specify an arbitrary script that will be used on buckets when they get rolled from cold to frozen. Again, this is from Splunk's point of view. This means you only configure one thing, which is the cold to frozen script. And you can have that script do whatever you want. It's going to take the path to that bucket directory as its argument, and then you can compress the data, you can encrypt the data, you can SCP it, you can FTP it, you can move it to a tape backup system. You can do whatever you want to. Splunk will respect the return value from that script. So it will then delete the bucket if and only if that script returned as 0. Any other value, and it's going to retry the script after a certain amount of time. So this sounds great. You can do whatever you want, but of course I've just moved the onus of maintaining this system from me onto you. So you have to make sure that the script is robust enough that A, you're not going to lose anything you didn't want to lose, B, that you're not going to fill up local storage on the indexer because the script fails too often, and C, that you have sufficient logging that you can diagnose problems when they come up. And on top of that, again, the data is still not searchable. You're doing something with it, you're moving it to a place where Splunk can no longer be responsible for it. So this is great, but it would be really nice if there was some option where we could keep the data searchable. It was fairly easy to set up and maintain, and you still had reasonable total cost of operation. And that brings us to the next option, which is hunk archiving indexes. So this is a feature which is included as of now with Hunk. If you install Hunk today, you can set this up and start playing with it. The idea is that when before a bucket gets rolled into Frozen, we're going to have already copied it over to some location on HDFS or some other Hadoop compatible file system, S3, CleverSafe, whatever you want to use. You're going to keep the same, the data is going to continue to be searchable with Hunk, so you can use the same queries that you were already using to look at your data. You can use the same dashboards you're already using to look at your data, with a few minor exceptions. And they're going to take a different amount of time to run, but they're still there and they're still available. So I'm going to talk a bit, very broad strokes about how this works. Periodically, the default is once every hour, a script is going to wake up and on the search head is going to tell each of the indexers to archive their data. Each of the indexers is then going to look for buckets that are ready to be archived. I'm going to talk more in a little bit about what that means. For each one, it's going to figure out where do we want to put this within the HDFS file system to maximize searchability later. And it's going to talk to the name node and say, physically, which machine would you like this to reside on? The data is then going to start being copied into the Hadoop file system. And as you can see, in most cases, we're going to have one indexer talking to one data node. That's very important. I'll get back to that in a bit. All right, so what's going to get copied over? We're trying to minimize what gets copied over to what's actually useful. Again, we're engineering this from the ground up for scalability. So we're going to copy over the raw data, so the raw data events of the events. Which is in a format called journal GZ. And that's the format that Splunk maintains the data in within its indexes to have fast indexing capability. We're also going to encode the timestamps of the earliest and latest events for each bucket into the path on HDFS where this bucket gets copied to. We're not going to copy over a lot of the auxiliary files that are normally found in the Splunk Enterprise Index, like TSIDX files, Bloom filters, metadata files, things like that. Those formats are optimized for quick search on a locally attached POSIX-style file system. They're just less useful in HDFS, where you're normally streaming the data in a highly parallelized manner. And we don't want to take up, they also can all be regenerated if necessary from the journal files. So what we want to copy over, we don't want to copy over anything that's not going to be useful in this new location. Again, for scalability purposes.
And so in terms of the storage costs that I mentioned earlier, one is that you're offloading to low-cost commodity storage on Hadoop, and the other is what some of the things that Keith just talked about in terms of what is it that we actually copy over to HDFS and what we don't versus a Splunk index.
Yeah, go ahead.
So are those files kept at all, or are they thrown away?
So you can choose what happens when the bucket gets frozen on the original index. By default, they will be thrown away.
Well, but you had said earlier that you could copy warm and cold buckets to HDFS as well.
Yes.
In those cases, are the TSIDX files and Bloom
No.
filters kept?
No, they're not useful for search within Hadoop.
Sure.
I'll talk more about search in a minute. We wouldn't use them if we did copy them. They could be regenerated if you needed them.
But those buckets still go through your standard aging process in Splunk index, and then we just copy over what we need over to HDFS.
When would you specify
Yeah,
what you want to happen to the buckets? The frozen data?
Oh, that's in the configuration files, and I will get to that in a bit. I want to, I actually think I want to keep other questions for the end, so I want to make sure I get through. Some of these will be more obvious as I get a few slides further on anyway.
We only have a few more slides.
So some of you may be remembering an application called Hadoop Connect, or maybe you're already using that now and saying, well, isn't that used for the same purpose? In some cases, yes. Hadoop Connect is a Splunk-supported application which we've put out there that can be used to export your data from your indexes into Hadoop. Also quite useful, but it has some downsides. It's not nearly as scalable as the new hunk archiving feature is. And if you look at how this operates, Hadoop Connect, there's an app sitting on the search head which runs a query periodically that causes all the data to be parsed out of indexes, sent to the search head, reformatted into Hadoop format, and then written out to the file system. So this means that this app sitting on the search head is now a bottleneck for all network traffic. It also means all of this data is being sent over the network twice instead of once. And it also means that the data has to be first parsed and then reformatted. If you compare the new archiving feature, by contrast, like I was saying before, each indexer is typically talking directly to the final data node. So we're not going through the search head, so there's no one machine bottleneck, except the name node. But even that you can configure with high availability Hadoop to have more if you need to. But it's maintaining a small role in this in terms of network bandwidth anyway. We are bulk copying the journal GZ files, which are already fairly compressed, which is a very efficient way to move data into a distributed file system. And we're not copying things that we're not going to use. In addition to that, if you're worried that you're going to max out your network between your Hadoop cluster and your Splunk cluster by having all this copying going back and forth, we provided configuration to allow you to throttle the bandwidth that's coming out of each indexer for purposes of archiving. So I said I would go through the configuration a little bit about how you do this. This is how you would set up an archive index. This will all be added to the indexes.conf file, and you're going to add a new stanza for your archive index. And it's going to contain things like the name of the index that is being archived, how old a bucket has to be before it's eligible for archiving. So I said I would get back to what makes a bucket eligible for archiving. The main constraints are it has to no longer be hot, it has to be at least warm, so it's no longer being written to, and it has to be at least this old in seconds. You then have to specify where on the Hadoop file system you want that archive to go, and you have to specify a provider. For those of you who aren't used to configuring hunk, a provider is an abstraction that provides all the connectivity information. So that's going to say where the name node is, where the job tracker is, or if you're using Yarn, the resource manager, etc. It's going to specify Kerberos authentication credentials if you're using that, and so on. In addition, you can add a bandwidth throttling configuration, like I mentioned before. And then I usually recommend that you add this to the original index. If you don't add that, then as soon as a bucket is ready to be frozen, it will be deleted. In most cases, you want that to happen anyway, but there can be cases where archiving is backed up for some reason. You have network breakage between the two clusters, or you just started this and you have a giant backup, and you're worried that things are not going to be archived before they roll over to frozen, or you're setting this number to be incredibly high because you want to make sure that the data exists in two places for as short of a period as possible. In those cases, you can specify this script down here, which basically means that when the bucket rolls to frozen, instead of being immediately deleted, it will be renamed. The archiver still knows where to find renamed buckets when it needs them. Important thing to remember, like we've already specified, this archive data still remains completely searchable using hunk. You know, if you, any query where before you did index equals foo, you now use index equals foo underscore archive and use pretty much any query that you used before. There is still one drawback, which is that a bucket for some period of time is going to exist in both places so just once. So if you wanted to count up all of the events that have ever been in foo, then you're going to get some duplicates if you say index equals foo or index equals foo archive. So that's why we've introduced unified search. If you set up unified search, then we make all of this transparent to the final user. You can just say search index equals foo, and you're going to search both foo and foo archive, and you're not going to get any double counting. The way this is implemented behind the scenes is that we intercept the query, and we say anything that's older than a certain point in time goes to the archive query, anything, or the archive index, anything that's more recent goes to the original index. So how would you configure this? We've provided two separate switches, one global switch. If, you know, for some reason, you know, for example, your HDFS cluster goes down and you want searches to continue normally anyway, there's a global switch where you can quickly turn unified search on and off for all indexes. In addition to that, you have the ability to turn it on and off for each index individually. So if you want to turn it on for an index, go to the archive index and add this. That's configuration that says more than this number of seconds before the query. If I set this to be the 2 weeks in seconds, then whenever I run a query, anything that's more than 2 weeks old, we're going to look in the archive. Anything younger than 2 weeks, we're going to look in the original index. Okay. So then the last issue here is, you know, now that the data is in HDFS, you probably have a lot of other HDFS applications that you want to use to access the same data. So what about that? Well, for that reason, we've provided a translator. This is the Splunk Archive Bucket Reader. It's currently available, it's free, it's packaged as an app. Today you can go to splunkbase.com and search for Bucket Reader, and you can add it. This basically it implements the various Hadoop classes that are used for reading in a new data format. Those who've configured Hadoop before probably know there's a CSV input format, there's an Avro input format, etc. We just created a Splunk input format. And this means that you can plug this into any of your existing systems. You can do live queries on journal GZ files without moving them. You can do an export action if you want to reformat them into a new Hive table or something like that. You have full freedom to do what you want with the data. It's important, one thing that I should mention is that what you have there is the data that's in, you don't have the late binding schema that Splunk normally provides. You're doing